Hello everyone, my name is David Morilla-Cabello. I'm from the University of Zaragoza in Spain, and I will present my work on robust fusion for Bayesian semantic mapping. Semantic mapping allows to obtain high-level understanding from scenes. Therefore, it is at the core basics of many automated tasks such as driving, agriculture, or service robotics. Not only that, but it can also help in more fundamental tasks such as navigation and mapping, as recent works have shown. So let's say that we have a measurement from our neural network to classify a certain object or voxel in our map. Current approaches can be broadly separated in two. The first counts the labels assigned from the network as the most probable class. The problem of this approach is that it ignores the confidence of the network. The second uses the probabilities and applies a Bayesian scheme where the posterior is proportional to the likelihood times the prior. This approach includes the confidence of the network. However, neural networks have shown to be overconfidently wrong, resulting in outliers. Also, this method still can't express the uncertainty of the model. Could you please raise your hands if your neural networks work as expected? Yeah, that's a complicated topic. Neural networks have limited knowledge from data. This results in the model having uncertainty upon data it didn't learn from, and, of course, the noise present in the data itself. Additionally, as I mentioned before, classifiers tend to be overconfident about its predictions. How should we fuse the predictions then? We start from the Bayesian fusion scheme, so in terms of the noise from the data, it can already be handled by the network confidences. However, in order to account for the overconfidence, we apply a regularization to the network output. This regularization can be understood as the probability that we think our network has to be correct in its confidence, and can be extracted from datasets during training process. Now, in order to account for the model uncertainty, we use a Bayesian neural network to obtain epistemic uncertainty. Then, we include this uncertainty in the Bayesian fusion. Let's see an example to showcase the process. We want to classify the region inside the black square. We obtain a measurement, apply a regularization, and then weight the fusion inversely with respect to the epistemic uncertainty, which is low in this case. If now we have a new measurement, which, be careful, it's an outlier, we again apply the regularization and then reduce its weight in the fusion given that the epistemic uncertainty is high. Here you can see how in this case the classification of the region is not affected by the outlier. To validate our method, we run voxel-based semantic mapping on trajectories with no poses using a photorealistic simulator and real-world datasets with different classes. We use two traditional methods used for semantic fusion and apply an ablation study on our method. In this table, I will only show the mean intersection over union and the accuracy for all the classes. You can check the paper for detailed results for each of the classes. As you can see, the proposed methods to robustify the semantic fusion contribute incrementally to the best of the results, resulting in a more accurate semantic mapping. Finally, here you can see some examples of the resulting semantic maps, where some regions like the sofa in the upper scene and the bed in the lower scenes are better mapped. As shown by our results, considering data noise, overconfidence, and model uncertainties in neural networks are beneficial in semantic mapping. Now, we are able to identify uncertain regions for our neural network, and outliers might be avoided. However, our immediate steps go in the direction of how to actually choose correct viewpoints that are not uncertain and that can improve the efficiency and quality of the mapping mission by selecting informative viewpoints for our neural network model. If your research is related to active perception planning and you would like to discuss some ideas, don't hesitate to come by my poster or contact me. Thank you for your attention.